What changed this week is that code agents are starting to look less like raw reasoning engines and more like systems that need the right environment to behave well. Cleaner repositories, static structure, and review loops don't just affect accuracy, they change how many tokens the agent burns, how predictably it navigates, and whether it can actually close the loop on a fix. That matters because the next bottleneck in AI coding isn't only can it solve the bug, but can it solve it cheaply, reproducibly, and in a way humans can trust. Let's explore the first paper. Does code cleanliness affect coding agents? A controlled minimal pair study. This paper from SonarSource asks whether code cleanliness affects autonomous coding agents when the repository and task are held constant. The authors build a controlled minimal pair benchmark on the Harbor framework with 6 behaviorally equivalent repository pairs, 3 public and 3 private, and 33 hidden test tasks routed through cleanliness, hotspots, or cross-module seams. Cleanliness is proxied by SonarCube issue density and cognitive complexity. Using Claude Code with Claude Sonnet 4.6, they run 660 trials and find that pass rate is essentially unchanged between cleaner and messier code. But operational footprint is not. Cleaner repositories reduce input tokens by 7.1%, output tokens by 8.5%, reasoning characters by 11.1%, conversation messages by 7%, and file revisitations by 33.8%. The strongest behavioral shift is revisitation, which drops about a third on cleaner code, suggesting the agent commits earlier and reopens edited files less often. Track-level analysis shows multi-module tasks account for most token savings, while cognitive hotspot tasks mainly change how work is distributed across files. A comment normalization ablation indicates that suppression markers are not the main driver of the effect, and the cleaner side advantage persists even after equalizing comments. The central takeaway is that maintainability principles still matter for AI-driven development. Cleaner code does not make Claude Code more accurate here, but it makes the agent cheaper and less navigationally uncertain. Let's explore the second paper. How much static structure do code agents need? A study of deterministic anchoring. This paper studies whether LLM code agents need richer repository structure than plain keyword search, using OpenAI's Codex with GPT-5, 1 Codex, on SwiBench Lite and SwiBench Verified. The authors introduce CodeAnchor, which runs lightweight static analysis offline with PyCG and AST extractors, then injects deterministic anchors as plaintext comments, encoding calls, inheritance, imports, containment, data flow, containment, and configuration usage directly into source files. The key finding is the deterministic anchoring effect. Static structure improves navigation discipline and reproducibility more than raw reasoning power. On SwiBench Lite, bidirectional call, inheritance tags raise func at 5 from 0.8321 to 0.854, cut rounds from 35.3 to 33.7, and increase pass at 1 on single run localization from 0.742 to 0.776. On SwiBench Verified, func at 5 rises from 0.6187 to 0.6308, and rounds fall from 42.4 to 40.9. The gains are scale sensitive. Dense annotations add little over basic topology and often cost more context, while inverse-only links help large, hub-heavy repositories. Trajectory analysis shows tags increase link following rate from 0.1, 50.1, 8 to 0.21, 0.24, and roughly halve run-to-run variance, confirming that static structure makes code agent behavior more predictable, not just more accurate. Let's explore the third paper, SwiReview, closing the loop on issue resolution with agentic code review. SwiReview from NTU, Huawei Technologies, and HKU reframes AI code review as a closed-loop mechanism for issue resolution rather than a post-hoc comment generator. The paper builds SwiReview Bench with 1,384 AI-generated pull requests from 500 SwiBench verified issues, and SwiReview Traj with 8,914 decision-correct review trajectorias, then evaluates agentic reviewers such as Claude Opus 4.6, GLM5, and Qwen 3 variants. Compared with single-turn fixed context review, agentic review improves both decision accuracy and downstream resolve rate, especially on non-local bugs. For Qwen 330B A3B, resolve rate after revision rises from 27.5% to 52.6%, while the generate review revise loop lifts Qwen 330B A3B from 27.5% to 56.9%, and Quinn3 Coder 30B-A3B from 50.9% to 68.8%. The strongest reviewer, Claude Opus 4.6, reaches 89.4% decision accuracy on one split and 81.8% weighted average accuracy with only 148 K tokens on average. And review-guided iterative revision outperforms verifier-selected best of n by reaching 38.4% resolve rate from a 22.9% baseline using only 2.44 samples on average. The key technical claim is that structured, repository-exploring review feedback is not just a gate, but a reusable supervision signal for training, revision, and test time scaling. That's a wrap on today's AI paper highlights. Thanks for watching.